So we're going to look at volume, starting with talking about a right prism. A right prism has lateral edges that are all perpendicular to the base, and all the faces are rectangles. The bases could be whatever shape they are, though. A cylinder, kind of similar. It's got a circle for the base, also a circle for the top, and then it would just be like a big rectangle wrapped around it. And if it's a right cylinder, that means it's perpendicular to the base. When you're doing volume for a prism, this actually works for a cylinder too. Volume equals the area of the base times the height. Area of the base times the height. So depending on whatever the base is, you got to find that area first and then multiply it by the height. So if it is a rectangular prism like this one right here, you need the area of the base, which would be length times width, and then times the height. So the area of the base is length times width times height. That's why we just say length times width times height. So for a right rectangular prism, that's what you could use. If it's a cube, that just means that all the sides are squares. So you need the area of the base, S times S, and then times the height, which is another S cubed. But it can all be summed up with area of the base times the height. If it's an oblique prism or cylinder, oblique just means slanted. Oblique just means slanted. So the sides aren't rectangles, they're actually like parallelograms. An oblique cylinder is just a slanted cylinder, same thing. It's not perpendicular. But we have this Cavalier's principle, which states that if the heights are the same and the cross sections are the same, they have the same volume. So really what that means is for those oblique prisms and cylinders, if the cross sections are all the same, so if the bases are the same and it's the same throughout, and the height is the same, they've got the same volume. So it's still area of the base times height, even if it's a slanted oblique prism or cylinder. So for this example here, we've got an oblique cylinder. We're trying to find the volume. So we need the area of the base times the height. We don't know what the height is yet, so we're going to do a quick little calculation to figure that out. Because we know the height is 3 times its radius. We know the area of the base is 81 pi. And we know the area formula for a circle is pi times radius squared. So we can figure out what the radius is. Pi's cancel, so that means r squared equals 81. So square root of 81, r equals 9. And if the height is 3 times the radius, 3 times 9, the height is 27. So to find the volume, we do the area of the base times the height. The base is 81 pi, and the height is 27. So we multiply that out. 2,187 times pi. You can either leave it with the pi symbol or you can use 3.14. Those rounded to the nearest tenth, so the 0.18 would round to 0.2 centimeters squared. Here's another similar question. The height is 4 times the side length. And we're told the base is a square. It's a square base. So if it's a square, area of a square is just side squared. So you take the square root to figure out what the side length is. Square root of 75 is 8.66. Around 8.7 if you want. And the height is 4 times the side length. Height is 4 times the side length. So that means the height is 4 times 8.66. It's 34.64. So we find the volume, which is the base times the height. You take the base, area of the base is 75, times the height is 34.64. $2,598 meters cubed. Take a minute to do this one on your own. So we need to do area of the base times the height. Base is a circle, so you need to do pi times radius squared to get the area of the base. So that's pi times 12 squared. And then times the height, which we're told is 45. So you multiply that out, you get 20,347.2 inches cubed. So now we're going to move ahead to pyramids. Very, very similar. It's actually almost the same formula. Volume equals base times height still, but this time it's times 1/3 or divided by 3. Times 1/3 or divided by 3 because it's a pyramid. So what that means is if you had the same area of the base and the same height for a pyramid and prism, you'd be able to use that pyramid 3 times to fill up the prism. So if you had a pyramid-shaped cup and a prism-shaped cup, it would take 3 of the pyramids to fill up the prism. Just because of that 1/3. So for this volume of this pyramid, it's area of the base times height divided by 3. 1/3 base times height. So area of the base is 24 by 24. There's your base. And then the height is 16. So 24 times 24 times 16, and then just divide by 3. 3,072 centimeters cubed. Cones, jumping right into them, because it's really the exact same thing. It's still 1/3 base times height. So if you had a cone-shaped cup and a cylinder-shaped cup, the only difference is the 1/3 in the formula, if they had the same dimensions. So we're going to step it up a little bit. This time we've got two shapes kind of put together. To find the volume, you just find the volume of the two different shapes and then add. So we have a cone up top and we have a cylinder in the bottom. So let's find the cylinder, and then we'll also find the cone, and then our final answer, we're just going to add those two volumes together. So for the cylinder, we need area of the base times height. To get the area of the base, we need to know the radius. We're going to do pi times radius squared. Here we're told the diameter is 16, which means the radius is 8. And then times the height, it's marked right there, is 19 millimeters. So using 3.14 for pi, we get 3818.24. Then for the cone, it's got the same radius because it fits perfectly on top right there. So the radius is still 8. So the base is pi times 8 squared, area of the base. The height, we need to calculate a little bit. We know the whole thing is 32 millimeters. The cylinder was 19 millimeters of those 32. So subtract. So that means the cone is 13 millimeters. 32 minus 19. So the height of the cone is 13 millimeters. So we multiply that out. 8 squared times 3.14 times 13 divided by 3, because it's a cone. So we found the two shapes, the cylinder and the cone, separately. Add those together to get the total volume. It's 4689.07, rounded to the nearest cubic millimeter. Don't have to worry about that 0.07. There's another composite figure. This time, though, it's like the pyramid has been removed from the prism. So it's got a little, like a hole cut out of it, kind of pyramid-shaped hole. So to do this, we can find the volume of the prism. which is area of the base times the height. Area of the base would be 25 times 12. And then times the height is 15. Then for the pyramid, it's very similar, except it's 1/3 base times height. So do 1/3 the area of the base, it's the same, 25 times 12, because it fits perfectly. Times the height is also the same, because it's got the exact same height, it fits perfectly. So for our final answer, we need to do the prism minus the pyramid, because the pyramid was cut out of it. So it was removed from that block. So subtract, get your final answer, 3,000 cubic feet. So we have another composite figure. We have a cube with an oblique cylinder on the top. So we can find the volume of the cube and the volume of the oblique cylinder and add them together. So we know that the cylinder has a radius of 5, and that fits perfectly on top of this cube. Which means that the cube if the radius is 5, the diameter is 10, so that means if the diameter is 10, that's also the length of the cube, the side length, because it fits perfectly right there. So this cube is all 10 by 10 because it fits the circle perfectly on it, and the diameter of the circle is 10. And then since it's a cube, that means the height is also 10. The cube is 10 times 10 times 10. And then the cylinder is area of the base times the height. So we need the area of the base, which is a circle, so it's pi times radius 5 squared. Times the height, we have to do a quick little calculation. We know that the cube went up 10. So if that whole height there is 22, 10 for the cube means 12 for the cylinder. So 5 squared is 25 times 12 times pi, or 3.14. You get 942. And then we said we had to add those two volumes together. So the total volume of this composite figure is 1,942. Dimensions are feet, so it's feet cubed. So here we have a pipe, which means it's got a larger radius and a smaller radius. But it is a cylinder that's hollowed out. So what you would do, there's no actual numbers here, so it's just a quick little explanation. What you would do is you would find the volume of the large cylinder. minus the volume of the smaller cylinder. So the large cylinder has a radius of, we're calling it R sub 1. R sub 1 is the larger radius. So that's pi times radius squared. And then it's got the height of h. Minus the smaller cylinder is going to be pretty much the same thing, but this time it's R sub 2 times the height. If you wanted to get a little bit crazy and practice some algebra, they both have pi and they both have h, so you could actually factor that out. And then just write what's left over. That'd be R1 squared minus R2 squared. Either of those two formulas is fine. So the last shape we're looking at is spheres, which is like a ball. The volume formula is different than all other volume formulas. It's 4/3 pi r cubed. 4/3 pi r cubed. So there's some similarities to circles in there, like the pi r squared, but this time it's cubed because it's 3D. So we're going to look at another composite figure. We have a cone with a half sphere on top of us. So we have the half sphere, and we have a cone. And together, to get the total volume, you have to add that together. So the half sphere, we need to know the radius because the formula for a sphere is 4/3 pi r cubed. So we need to know the radius, which is there is 5. Be a 1/2, not a 1/4. And then the cone, pi r squared times the height, same radius, times the height. I actually don't give you the height here. I'm just going to give it to you. It's 12. It's supposed to be labeled there as 12. So we're going to get the two volumes and add them together. So for the sphere, we're going to do 5 to the 3rd power. 5 times 5 times 5 times pi times 4/3. And then times 1/2, or just divided by 2. So just round it to the nearest cubic centimeter. I'll keep 0.7 for right now, and then we'll round at the very end, because there's 0.6 repeating. Then we do the same thing here for the cone. 5 squared, 25, times 3.14 times 12. And the part that I forgot to write down is the 1/3 because it's a cone. So divided by 3, after you multiply that all out, you get 314. So add to get your total volume is 575.7. Rounded to the nearest cubic centimeter would just be 576. We have a cylinder with a half of a sphere cut out of it. So that means we're going to subtract half a sphere. Another thing that's kind of tricky about this is you don't know the height of the cylinder, sort of. It's hidden. So we need to know the radius, which is going to be half of 7. So the radius is 3.5. Since that is a sphere, that means that that's the same radius right there to get from the center down to the bottom of the sphere. So that's also 3.5. So for your cylinder, you do pi times radius squared times height. And then for the sphere, you do, it's a half a sphere, so you do half. Formula for a sphere is 4/3 pi times radius cubed. And plug in the numbers that we identified here. The radius is 3.5. The height is 3.5. And the radius is 3.5. So for the cylinder, it has a total volume of 134.6. And then the half of a sphere has a volume of 89.75, so we'll say 89.8. So when you subtract, you have a total volume of 44.8 cubic inches.